Okay, and hello from Vancouver. Today we have a live stream event at the CIM convention here in Vancouver City, and we're with the AMC in Vancouver team to talk about cost control and some of the trends that are happening in the technical space here at AMC. So we'll get onto that in a moment, but first off, we're here with our host, Maud Shannon, and just interested, Maud, how are you finding the convention today? And it's been a long time since people were able to get together, and what are your thoughts so far?
Yeah, well, it is, as you say, absolutely wonderful to be all together and to have a face-to-face conference after a couple of years, and it seems to be very well attended. There's a great buzz here in the exhibition floor and the expo part. I understand that there's some very interesting talks going on, and it is well attended. So yes, it's very exciting.
Cool. And have you been busy recently in the office?
AMC in our Vancouver office is very busy
at
the moment. The industry is buzzing, I think we could say. Lots of people looking to do lots of things, and we are very busy.
Cool. All right. Well, we'll let you get back to it, and we'll bring in the technical experts and get on with the discussion. Thanks, Maud. So today we've got Tony Grice and Kingsley Hortin from the Vancouver office here to talk about trends that are really relevant at the moment to the industry here in Canada and around the world. So perhaps just starting with you, Kingsley, on the ventilation side, electric vehicles are topical at the moment. Everything's a buzz around battery-operated vehicles. Have you seen much uptake in it?
Absolutely. Canada seems to be one country that's really taken the electric vehicle technology and really run with it. There's a couple of mines already that have very much used it to a great deal. We have the Macassa mine, which has got quite a number of LHDs and trucks that are electric, battery operated, running around underground. And then, of course, we have Borden mine, also in Ontario. And they basically started that mine with the concept of there won't be diesel vehicles underground. So it's been very much something that Canada has taken on. And also quite a number of the other mining companies, Vale, Glencore, Agnico Eagle, Newmont, are also doing either trials or looking at actually implementing battery electric vehicles in their underground operations and future plans.
Cool. We've also got David Vink on the line from our optimization group. David, just thinking about the battery-operated vehicles, can you see many opportunities for cost improvement and real changes, sort of momentum shifts in the industry around adoption of battery vehicles?
Yeah, we certainly do, Mark. Specifically in the longer term, there are significant advantages, and they're likely to be realised in terms of reduced ventilation costs and productivity improvements, particularly where ventilation might be a constraint in a mine. In the short term, so in the very short term, large-scale battery electric vehicles are still under development, and our independent analysis indicates that they're a little higher cost than diesel, especially when it comes to the larger trucks and loaders. However, it's possibly just a matter of time before that changes, particularly when we see the benefits that are associated with the reduction in diesel emissions in underground mines. So while the technology in terms of broad scale use continues to be proven, in the longer term, the outlook is positive.
Do you see just the major equipment providers, pushing forward with this, or are there other niche providers that are in the market now with perhaps even some innovative technology that can be used?
There are certainly opportunities. The major OEMs are manufacturing battery operated vehicles, which have facilities in underground mines, in particular, for those batteries to be replaced efficiently and effectively, because they have a limited amount of time during which they can power the vehicle without a recharge. So it's becoming a mainstream off-the-shelf offering from OEMs. And in particular applications in underground mines, they're finding a ready use.
Yeah. Back to you, Kingsley. With the adoption of these systems, are we seeing a need for additional capex to be spent elsewhere, or is it a reduction in capex? Is it,
So I guess, yeah, as David say, probably the capex involved in both the initial purchase of the equipment, and another supporting capital purchase in the area of recharging and that sort of thing. Certainly there are some capex costs involved there, but as David was saying, we do have a lot of potential reductions. A study that we've just been working on, we had a look at the amount of air that would be required compared from a diesel to an electric, and there was about a 40% reduction in the amount of air required to ventilate for a battery electric vehicle, and that's really just to deal with the amount of heat that's being generated, along with specific issues like dust and ultimately at the end of the shift blast fuel removal and that sort of thing. But there's definitely some savings to be had there.
Yeah. Does the regulatory environment need change, or how are they adapting to it as well?
Okay, so we've certainly come across this on a couple of occasions because the technology is new, and often as happens, regulations take a while to catch up. It's somewhat, I wouldn't say untested, it's just a little bit, takes a little bit of a gap between introduction and acceptance and developing appropriate regulatory framework. However, what we're able to demonstrate to these regulatory bodies is the reduction in emissions, and particularly with regards to diesel particulates and other contaminants like that. And so we can work with mining companies to help them show the regulators that, hey, yeah, we can reduce the ventilation, but ultimately it's going to be safer.
Okay. All right. Well, just moving on then to bring Tony into the conversation. Thanks for joining us. Looking at the backfill areas, what's topical at the moment in that area, and what trends are you seeing in the industry?
So yeah, I think the biggest trend that we've really noticed in the last 2 or 3 years, probably going back a little bit further, is more of a requirement for mines to place fill underground as a result of wanting to make surface tailings storage facilities smaller, more easy to manage, safer, and have less environmental sort of roll-ups at the end of the life of mine operation. So that's where that started to impact is mines which have probably not been doing backfill in the past in any engineered sense, but just waste rock disposal. We've done a couple of studies, and 2 of those were in Brazil, looking at mines where there was no prior backfill in place, but there was a requirement to reduce or not to get an extension on the surface tailing storage. So what we're able to do in conjunction with the clients and the local engineering companies there was come up with a design where we could place classified tailings back underground. So we were diverting all of the expansion tonnages down underground and not requiring further tailings storage construction beyond the planned and approved levels, and place that underground into the voids. So the simple solution was just to put that material underground into the very large open voids. It was a mature mine that had been working for a long time. What we also did was a study alongside and said, well, if you cemented some of that tailings, so you could do an engineered fill, could you then recover some of those old sill pillars and rib pillars that have been left behind? So we went through the exercise of looking at that and what would be involved. What we showed, in fact, was that yes, you could use a lot of bulk fill, which is very cheap to place underground, but adding cement, and although you're adding a bit of cost to the backfill system, what it showed that it improved the net present value of the mine by about 10 to 15%, because you're suddenly having all of that additional ore exposed that you could then actually mine as part of the future mining system. And that in itself then justified the expansion, because there was more ore in total that was able to be mined.
Yeah. So David, is that what you're seeing in other jurisdictions as well? There's opportunities for us to optimize the disposal of materials underground, and obviously engineered fill, and really look at it strategically from a company perspective to improve the cost performance and maybe other objectives as well, which is getting rid of tailings dams, I guess.
Yeah, absolutely, Mark. There's tremendous opportunity with this technology, and the way in which backfill's being used, particularly paste fill, and the evolution of that method in terms of backfilling underground mines over the last decade or so has been tremendous and resulted in very positive change in mining sequencing in underground mines. One of the very, very strong benefits that we see in mines with poor ground conditions is the capacity to do underhand fill mining techniques. And this is a huge benefit in mines which experience geotechnical issues with very poor ground, because the backfill itself, installed in the right fashion, can create a stronger working area than the existing ground itself, and that has all sorts of advantages in terms of assuring the mining process, on schedule performance of mining operations, potentially greater recovery of reserves. So, really has strong potential. Now, they're all benefits in terms of underground mining, but at the same time, utilising tailings underground reduces the surface footprint and has benefits in terms of that area of disturbance above ground.
Yeah, it's interesting, these trends that we're seeing here in Canada. Have you had an opportunity to look at any operations here recently, to do some benchmarking studies, even to just get a feel for what sort of changes we're starting to see?
We certainly have, and particularly around the Sudbury area, where we've been engaged in reviewing mining operations. We've seen paste fill in application. We've seen traditional sand fill, and so we've experienced the breadth of applications of those methods. We can see in the mining schedules at those operations that use paste fill, particularly in more narrow vein environments, the reliability that comes with achieving the mine plan. So just that nice alignment between the actual results in terms of stope turnover and the plan.
Yeah, I think that's a really good point, that it results in a deliberate plan and a confident outcome that comes from what we're able to do and offer. So that's a really good opportunity. Just also interested in the other big theme that's come out in the last year or two is digitalization. So using of gathering, analysing, and using data in future mine plans. So, what sort of trends have you seen, Kingsley, in the ventilation area in collecting and using that?
Okay, so one thing that become certainly more widespread is the distribution of the communication networks underground. What used to be leaky feeder is now much greater, and we're collecting information, especially about airflow, gases, temperatures, other contaminants, and we're able to adjust the ventilation systems as a result of that. Now, we usually call that ventilation on demand, but it's becoming a little bit more focused. It's integrated more with some of the ventilation modelling systems out there, and we're able to make real-time decisions and not only improve the ventilation for the areas that require the ventilation, but reduce ventilation in those areas that don't need it, and overall come up with on a day-to-day basis, much more efficient ventilation system that better matches the production requirements of the mine.
So is that sort of helping in risk mitigation as well?
Oh, absolutely, practices? For sure. And yeah, for sure.
Yeah. Okay. All right, and of course in the backfill area, what sort of advancements or what are the measuring opportunities?
So, as Kingsley says, the big change has been having data networks underground, fibre optics to main and sub-levels, and the ability to transmit information in real time back to control room operations. So in the early days of backfill, it was one controller and an analog board with switches and buttons to press. Whereas now the control operator can make use of pressure sensors put into the paste fill lines to understand what the flow conditions are, flow meters to understand the rate at which the fill is being placed underground, and having live video at the entrance to the stopes with flood lighting and being able to see the fill going into the stope itself to monitor, particularly when you're coming up to the level, so that you don't overfill the stope and they get spillage of material and have to do all the knock-up, clean up from that as well. And that data then is all part of usually the process control system in the mill, so it's all readily accessible through the databases. That means you can then go back and do QC analysis on it, both on the primary delivery of that fill, and then in conjunction with manual strength testing, you can then work out what fill strength, what cement addition was, what's the quality of the fill you've achieved there. So you've got this real-time picture of what's happening as you place it, a follow-up quality control on how it is performing. And then with tools like CMS and laser scanning, now the new drones to get in to look at all those awkward little bits of stopes, we can have a real view of what fall off of fill or rock or ore has actually occurred, and we can quantify that. So in a first stope that's had all that information where you calculate it, the engineer now has a lot of information to design the adjacent stope and to minimize the dilution of the future ore in secondary pools and everything. So it relies on that data systems in there, the digitalization of that to provide that information. And it's being used incredibly effectively on mine sites.
That's interesting. And Dave, do you see opportunities for that in downstream planning for improvement of developing and implementing more effective plans by having this feedback loop on a real-time basis?
We definitely do, and the availability of data is something that's improved in the ventilation and in the backfill space, so in those disciplines in the mine, but it's also improved across mine sites generally speaking. So the capacity to have data through fleet management systems and through fixed plant monitoring systems is there, and it's at a very high level. It can certainly be a range. We see mines where those processes of gathering data are still relatively manual. Then we see mines that employ spreadsheeting techniques. Then we see fleet management systems. As we go up the scale in terms of advancement, we see control rooms and remote control through to full IROC systems, so integrated remote control operations. So that full cross-section of data gathering capabilities exists. The key thing there is that the information becomes available no matter what technique is used, that the data is made available and that it finds its way back into the mine plan for use in the future. So the tie back there is that the available data is employed and used as best as it can be for the creation of good mine plans that reflect clearly what the outlook will be in the future.
What about the idea of scale as well? I mean, do operations or do companies need to be on the scale of Vale, Glencore, or BHP to implement these systems, or are relatively small companies able to take advantage of some of these advancements and put systems into place quickly and easily?
I think there's something there for everyone, and it's not a one size fits all is probably the other thing to say. So the best systems are the ones that are right for the mine's unique situation. So the combination of their level of advancement now, their economics, and their maturity, so their capacity to use the technology that's available. So it should really be approached on a case-by-case basis and right-sized to suit. And that might mean that it's not necessarily a fully remote control system that's appropriate for the mine. That might not be economic, or it might not be appropriate. It could mean that some advanced data gathering systems are the next step forward for that mine, and a good example of that is a fleet management system.
Yes, so you can take advantage really of off-the-shelf type systems to coordinate a lot of this data control that's floating around.
Absolutely, and it creates the opportunity to, in the first instance, make the gathering of data accurate and a little bit less manual.
Yeah. Well, it's interesting how that plays out. So are there other trends that you're seeing? Where do you see us in 5 years' time? I mean, we've come a long way in the last 2 years with data control. Where's this leading us?
Better understanding of how our systems are working, I think, is really where it's coming from. Mining is not a precise technology. We don't go much beyond the second or third decimal point, and it's not nano scale on anything we're working. So, and particularly in the backfill area, every single mine tailings that we make backfill out of is different. It's a different mineral assemblage. So the understanding of the technology of how that actually works, but it also needs the backup of the science and the research that the universities are doing, looking at all these sort of materials. And so we understand things like fluid mechanics of delivery. We need to understand the geotechnical engineering requirements for the consolidation of fill in the stoves and how it cures, how it behaves, how the stresses develop. And so there's really good institutions that are doing all of that sort of work, and we are piggybacking on and working with those institutions to understand the basic science. So again, we can apply it back to the technology. Technology tends to lead. We do something, but we don't necessarily understand everything about how it works. The science comes back to it and explains it to that. From that, we can come up with better and safer systems all the time.
Yeah. Do you see potential to link this back to the original resource model, and the predictive geometallurgy is one of the key opportunities to improve the strategic plan for a whole number of reasons, not just grade into the plant, but also impurities, etc. And maybe there's an opportunity to be writing some of these backfilling properties into those algorithms as well, and using the AI opportunities.
I think there's a lot of potential there. There's one of the mines here in British Columbia has a paste fill system, but they also have a lot of clay minerals and clay class minerals in their tailing stream. And there's some very unusual behaviors that sort of come from that. So the system has been designed around that variability. But in terms of the geometallurgical database or a block model of what the mine is, that can be located so that you actually know when particular stopes are being mined, which are the high play stopes, which are the low play stopes, and you can then adjust the operating parameters of the paste fill plant to cope with that.
Yeah.
Increased density, increased cement, reduced cement, what it is actually required.
Yeah, no, I think there's increased opportunities for each discipline to be overlapped with others, whereas perhaps in the past they were quite discrete. But I think in the future there's increasing opportunities for this to happen. And I guess, David, you would see a lot of this as well in advisory, where we're really trying to integrate the geometallurgical aspects into strategic plans, and really levering off the information you see in the benchmarking as well.
Absolutely. And there's a lot of work that goes into defining an ore body, drilling it out, and then a tremendous amount of capital and operating cost involved in setting up a mine to access that ore body. The key thing is that when we're extracting the ore, that we recover as much of the mineral as possible. So the deeper the understanding we have of the geometallurgy, and the closer that connection is to the design and operation of the plant, the better the outcome for the operation in terms of recovered minerals, having spent all that effort in getting underground and accessing that ore and bringing it to the surface.
Absolutely. All right. Perhaps just also interested in a thought from you, David, about cost trends. We've started to hear in the last month or two that inflation's taking in holds. Obviously, fuel prices are up, energy costs are rising. Are you starting to see some of that feed through into average cost of production on the operating side?
Yeah, we definitely are. There's an immediate effect from the cost of energy through to the cost of mining. So those outcomes are very direct. So if the price of fuel or the price of power increases, the price of mining and the price of processing increases. And those significant rises that we've seen are driven initially by demand recovery in the post-COVID era, now exacerbated by issues that we're seeing with conflict and supply interruption that's been caused by that. The net impact of those things goes to the price of gas, it goes to the price of coal and the price of energy. We track those numbers very closely, and our clients are very interested in them. One of the interplays there has just been the commodity price cycle that we've seen across the board. So in base metals, in precious metals, in electrification metals such as lithium and cobalt and nickel, prices have been very, very high, and for a long time. And we know that the growth outlook that the IMF says that that we have had that peak in terms of recovery in the post-COVID era in the last calendar year, and going forwards we're seeing that come off. So probably from a a global GDP growth of around 6%, dropping down into the 3s and maybe in the 3s for the next couple of years. So our clients are looking at those economic outcomes, and they're wanting to shore up their future. So having had high prices and being able to operate with costs under control, they're now turning their attention to cost pressures that have been brought on by energy pricing, but also by a general increase in some of those things that are scarce in terms of mine resources. And they're wanting to shore up their operations. So they're wanting to ensure that if prices come off a little bit, that they've protected their operational futures and their company futures by controlling costs. So we're seeing engagements now from companies that are still experiencing relatively high commodity prices in their spot sales, looking to shore up their futures and control their costs by bringing their cost base down. So that's the key thing for a lot of inquiry at the moment.
Sounds good. All right, well, let's probably got over half an hour at the moment. So just in wrapping up, any other issues that are pressing that you guys would like to bring up?
I think it's always improving the productivity of our systems that we're working with, we're designing and trying to improve things, to improve the stope cycle, shorten it so there's not so much capital that's being put ahead of the operating mine itself, to make those more robust and also to make them more flexible. What you need to do is not provide the optimum design. What you need to do is provide the optimum flexibility that can be operated at that mine, and so the managers can reach their targets with reliable, safe outcomes on there. And backfill is one of those things that if you've got a good system in place, particularly paste backfill, that helps you on that journey.
It's going to work quite well, and I guess similar with you, Kingsley.
Oh, very much so. And as Tony mentioned there about the safety side of things, that's one thing that talking about technology before that enables us to implement safer systems, be it through the reduction of diesel particulates, other contaminants by replacing diesel equipment, and other ways of manipulating, if you like, the ventilation system to better direct the correct amount of air and the correct quality of air to the correct places. And not only is that safer, but that also enables the best productivities to be achieved and the relevant cost outcomes as a result.
Okay, well, that's probably a good place to finish. Thank you both very much for spending the time today on the booth. We're here at CIM today, tomorrow, and Wednesday, I believe, as well. And it's a good vibe here, and I think it's good for everybody to be back face to face again and enjoying this atmosphere. So thank you, everybody, for attending, and thanks, Dave, for dialing in. And look forward to talking to everybody again soon. Thanks very much.
It's a pleasure. Thank you, Mark.